How to create metallic castings using the Smooth Cast 325 and real metal powders. Now in today's video we're going to show you how you can do metal castings on your own using a process that's called cold casting, where we take real metal powders and fuse them into casting resin to create these amazing looking castings that look like they're actual metal. Now our project today does have several goals. Number one goal is of course to make castings that look metallic, so they're actually made out of the real metal and feel like they're made out of the real metal. Our second goal is to keep the cost to this project low, creating a cheap alternative to the foundry. And if you ever work with foundries, you know there's a long wait, several weeks, maybe even several months sometimes. So we wanted to create a fast turnaround, creating a quick setting mold and a quick setting casting. Now let's just jump into this project and see how it's done. To start the project, we first need to set up our model onto a piece of clay. And for that, we're gonna first cut up some of the Sculptex Soft. This is sulfur-free oil-based clay. I usually embed my models in clay to make two-part molds, but in this case we're going to use both clay and alginate to make the first half of our two-part mold. And the reason why I'm doing this is I'm raising the model so we can pour the alginate halfway up our model. So we're going to make a parting line halfway, and here you can see me using the level, making sure that our model is leveled, again because we're pouring up to a line and we want that line to be straight on the model. Now the back of this wrench does curve upwards, and in order to be able to make a two-part mold, the back does have to be built up with clay. The rest of the wrench we're going to pour in alginate, but this back area we do need to build up clay in order to make it a two-part mold. I'm going to show you in a graphic exactly what I mean here. So, like I said, most of the model, the wrench is going to be embedded in the alginate, but in the back of the model where the wrench actually curves upward, that had to be built up with clay, because here you can see if we pour the alginate, it cannot flow up the back, so it's going to separate the mold in two halves along the parting line. And then we can go ahead and focus on building a mold box around our model. I'm simply going to use some melamine board that I cut to size to fit this model, this mold box model. And then before I actually finish the mold box, I'm going to go ahead and put some keys into the clay. So I'm going to use a acorn nut and simply push some keys into the clay. So when we make our first half of the mold, those keys are going to register in the silicone. And here just the last part of that mold box, and the reason why I'm using the plexiglass for the mold box here is to create a window so you guys can actually see inside the mold as I'm working with this. To create our parting line in our mold, we're going to be using the AccuCast Bucket Gel 390. Now, the 390 actually stands for 3 minutes working time and 90-degree Fahrenheit water temperature. That means that the material that you're mixing in the water, the alginate, will set up in 3 minutes time. So from the time that the material hits the water to the time it actually sets up, you have about 3 minutes of working time before the material starts to thicken and set up. Now, the AccuCast can be either dispensed by weight or volume. I'm going to go ahead and dispense it here by volume, which is 2 parts alginate and 3 parts water. So I'm going to go ahead and dispense that. Now, it's really important that we use the correct temperature of the water. So the water should be 90 Fahrenheit, and here you see it's 93. So by the time I dispense it into my cups and my mixing container, we're going to have the perfect temperature for this product to work at 3 minutes. So I'm going to go ahead and mix the powder into the water. As always, you want to mix powders into the water. As you can see, I'm using a turbine mixer here with a mechanical drill. Again, your working time for this is 3 minutes, so work thoroughly, but work fast. After drill mixing, I'm going to come back with a mixing stick and just scrape the sides and scrape the bottom off the mixing container, making sure there's no unmixed material ending up in our mold box. Now I can go ahead and start pouring that material into the mold box. Again, we want to focus on pouring this around the model, around our object, because the material is thick and doesn't flow quite as nice. So simply going to go around the model and fill that up to the parting line, so halfway mark off the model. Now we're going to allow this 3 minutes to set before going ahead and cutting some vents and keys. 3 minutes later, after the alginate has set, we can use a sculpting tool to basically cut some channels into the alginate. These will become keys on the other half, on the second half of the mold. So while negative in here, they become positive parts once we pour the silicone. Now here at the top of the wrench, this is going to become the pour spout. It's one of the highest point of the model. And then we're going to also need an air vent, and that's going to be the other side of this wrench. So right here, this is going to be the air vent. So keep in mind, as we're pouring material into one side, you want that air to be able to rush out of the mold. And it cannot rush out through the pour spout because there's material being poured. So we do need an air vent to allow the air to escape out of the mold. Just having a pour spout is not sufficient. For the mold making portion of our project, we're going to be using the MoldStar 20T. Now, most important aspect of this project is that it has to have a fast turnaround, and that's one aspect why we're using the MoldStar 20T. It has a 6-minute work time and a 30-minute cure, so it's extremely fast curing. The T in the material stands for translucent, so if we needed to, we can actually see into the mold and make sure that it actually fills with material before we stop pouring. Because this is a 1-to-1 mix ratio by volume, we don't need a gram scale. Simply mark the dispensing cups and proceed to dispense the part A and the part B. We can now go ahead and mix the part A and part B in a clean mixing container. As always, scrape your containers out, don't waste any product. And when you're mixing a translucent product like the MoldStar 20T, always scrape the side and scrape the bottom really thoroughly. But keep the work time in mind. We have 6 minutes from the time that the A and B are combined to mix and pour. So scrape the sides, scrape the bottom, work quickly and thoroughly. And then here I'm going to do a double mix. I'm transferring the mixed material into a secondary clean mixing container. And then I'm repeating that step of scraping the sides, scraping the bottom, giving it another thorough mix, and then quickly pouring it into the mold box. The silicone is now poured in a single spot and allowed to seek its own level, therefore pushing any air bubbles away from the model, making sure they're not going to be trapped on the model surface. Now, the reason why I'm propping up this corner here of our mold is to force the silicone to kind of flow down towards the end of our mold where the wrench, the model, was kind of curving upward. As you see in this graphic here, the silicone level on the right, where the wrench curves upward, is much lower than on the left. And by lifting that left side, now we're forcing the silicone to flow towards the right. Allowing the silicone now to level out will create an equal thickness throughout your mold. The liquid rubber should level off at least 1/2 inch or 1.3 centimeters over the highest point of the model surface. Now, if you were to keep this flat and pour that silicone 1/2 inch above the highest point of our model, you would actually have a lot of extra silicone that you have to pour. On the left here, you can see that that would be a lot thicker than on the right. So by tilting the mold like this, we're avoiding having to use extra silicone, therefore saving us some material cost. The material is now allowed a full cure of 30 minutes. After the MoldStar has cured, we can go ahead and remove our mold box. And then we're going to flip the mold upside down and remove that alginate. As you can see here, it comes off one piece, and then we're going to go ahead and remove that clay as well that we had to block off that round area of the wrench. To customize the castings coming out of this mold, we're going to add a little bit of the Sculptex sulfur-free oil-based clay to this wrench right here, and we're going to make it a little personal. We're going to use my stamping tool set here and actually embed Smooth-On into the clay that we put onto the model. A stamp set like this with letters and numbers you can purchase at almost any hardware store. They come in different font sizes and shapes and designs. My personal one here I picked up at a estate sale, and here you can see I'm adding the writing Smooth-On the wrench so that we can cast these, and gonna have the company logo basically imprinted on them. So now we can go ahead and put our mold box back together. Now, the release agent I'm using here is the Ease Release 205, which is the liquid version of the Ease Release 200. Now, the reason why I'm using the liquid version over an aerosol is that I can brush this into specific areas, very concentrated, to ensure a thorough coverage versus an aerosol can, which kind of sprays all over. So with a clean, dry brush, I can now apply the release agent over the silicone. And as a side note here is that you don't want to let the release agent puddle or pool in the mold. And I'm simply going to allow the release agent to dry for 20 minutes before proceeding. For the second half of our silicone mold, we're going to follow the same dispensing and mixing procedures that we did for the first half. And once the material is thoroughly mixed, we can go ahead and pour it into the mold box enclosure. And as for the first half, work fast, yet work thoroughly. Keep in mind the work time of the material is short, and we want to make sure that the material is mixed and poured into the mold box fast, and now is allowed a full cure of 30 minutes. Once the silicone is fully cured, we can go ahead and demold our model. I'm simply going to pry this mold open, and you can see how easy that pops apart with using the right release agent. And there's our model. We can go ahead and get that out of our mold, and then we're going to prep the mold for the actual casting process. Any of the extra silicone that seeped out on the sides can be easily trimmed using a razor blade. Now, one more step here, our pour spout and our vent need to be cut out. These were cut into the alginate when it was first cast. And when we poured the silicone into the alginate, that created a positive inside the first half of the mold. Now that positive is being cut out to actually create the vents. So it's a really nice technique that you don't have to put anything as far as in your model. You can just cut these out once your mold is complete. The mold is now strapped using some clamps in between two pieces of melamine board, and we're ready for the casting process. For the casting of our cold cast project, we're going to be using the Smoothcast 325. The reason why fast-setting materials such as the Smoothcast 325 are ideal for cold casting projects is because of their short pot life, and that allows the material to stay suspended in the resin just long enough for it to start to gel up and set up so that it's captured in the face coat, or in this case throughout the entire casting. Now, this product is a 1-to-1 mix ratio by volume and is considered a color match product, which means it's translucent. Now, it does have a short working time of 2.5 minutes and a full cure time of about 10 minutes. Now, that is also dependent on quantity of the mass that you're casting. Now, besides the casting resin, we are going to be using some real metal powders. And for our casting here, I'm using the brass powder. This is actual metal powder that was ground down, so it's actual brass. This is what is suspended in our casting and gives our casting the final metal finish when we polish it. The mix ratio of the Smoothcast 325 is 1:1 by volume. We're also going to add 1 part of the metal powder, so that's why you see 3 cups here. We can go ahead and dispense the part B, and then we're going to dispense the metal powder. Again, same amount, 1:1. Once we have the 2 dispensed, we can go ahead and mix them together. Now, I do add a little bit of pigment to my cold castings. I personally like to mimic the colors of the metal that I'm casting, so I'm adding a little bit of So Strong brown and then So Strong yellow to mimic the brass colors. Keep in mind also, when you add the brass itself, it will add color to your resin. But I do like to add a little bit of extra kind of just to reinforce the color in my castings. So now the metal powder is added to the part B, just like the pigments, and mixed in thoroughly. And this is happening before we even dispense the part A. Again, the part A is sensitive to moisture, so you want to keep that in mind and don't dispense it and have it sitting on your workbench. Now the part A is mixed into the metal powder and the part B mixture. And then the 2 components are mixed together. Again, mixed thoroughly, but work fast. The working time of the Smoothcast 325 is 2.5 minutes. So we do have to work fast, but thorough. And once you have the material mixed, you want to get it into the mold as soon as possible. Pour fast, don't delay, because the material can set up very easily in your mixing cup. The rocking of the mold that you see here basically allows any air bubbles that are trapped in the material to travel upwards. When you're adding powders like the metal filler to any resin, it makes the material thicker and makes it easier to entrap air. By rocking the mold like this, we allowed any trapped air bubbles to automatically release and travel upward and out of the mold so they don't end up in the face coat of our casting. The Smoothcast is now allowed a full cure, which would be usually about 10 minutes, but because this has a thin cross-section in the handle of the wrench, we're going to give it a full hour to cure. So it's been about an hour and our casting has fully hardened. We are ready to demold it. And as you can see here, even the thin cross-section, the main body of the wrench is fully cured and rigid. So that's the big difference between a 30-minute cure where there's enough mass for the material to cure versus a wrench like this that has a very thin cross-section. The pour and vent spouts are simply snipped off using some pliers and can be sanded to a fine finish. Now to finish our casting, we're going to give it a buff. We're going to be using some steel wool for this. The steel wool that we're using is triple oaked steel wool, and it gives the casting a nice polish and brings out that brass powder to shine. Our casting looks and feels like it was made out of real brass. Because of the metal added to our casting, it also weighs quite a bit more. The casting process can now be repeated with either the same metal powder and use brass, or you can use different metal powders to achieve different looks. I wanted to show you one more casting with the brass powder, but in this casting I actually remove the casting from the mold prematurely. So I removed it after about 20 minutes of curing in the mold, and it's not tacky, so I can peel this out. So you can see here that after 20 minutes of curing, that casting is quite flexible and I'm able to easily maneuver it. So here I'm going to simply cut those pour and vent spouts off, and then I'm going to maneuver the wrench into a position that I want it to be when it finally hardens. Slowly I'm bending it and twisting it into basically a tie. I'm going to tie a knot into this And here it's important to work slowly because you're actually changing the shape of the object itself. And then once you achieve the shape that you like, you can simply put some tape on it to keep it in that position until the plastic has fully hardened and is rigid. Keep in mind that thin cross sections like this wrench will take longer to cure, so we're going to allow this a full hour to fully harden. After 1 hour, the casting has fully hardened, and the tape that we applied can now be removed to reveal the shape of our casting. Now, the casting is fully rigid, as you can see here, and will retain the shape. Now, the addition of the shoe polish to your casting will add some depth and perspective to it, because some of those fine cracks and grooves are going to get filled in, and it's going to make our casting look so much more realistic and lifelike. So adding something like this will go a long way in convincing the user of the tool that it's actually real. And here again, you can see that realistic look with the shine, yet the dull areas in our casting. Here you can see the two side by side, our original wrench and our brass casted replica. And as you can see, the smooth cast 325 wrench with the brass powder has captured and replicated all the details from our steel original tool. And here you can see that different metal powders are available from Smooth-On. We have brass, bronze, copper, nickel silver, and aluminum powders available for cold casting. Now, a cold casting technique like this is a much cheaper alternative to real foundry work. Casting this wrench with the brass powder ended up costing about $20 worth of urethane resin and metal powder. Now, compare this to a real metal casting coming through a foundry, which would cost us anywhere from $80 to $140. This comes a much more affordable way to create metal-like effects. Now, if you got inspired by our project here and you would like to give your own project a go and need some material, you can get some by visiting any one of our distributors around the world. And there you have a step-by-step procedure that I use for metallic-looking finishes in my casting resin. Now, remember, we were able to create metallic-looking castings using the real metal powders, and we were able to keep the overall cost on our project low by using alternative to foundry work. And because we were able to fast turn around this mold and casting project, we didn't have to spend a long time waiting for somebody else to make it, but instead we were able to make a mold and our first castings within 4 hours of the start of this project. Now, if you have an idea about what we should do next, please let us know down in the comments below. If you like this video, hit the thumbs up button. To keep up with our latest mold making and casting videos, remember to subscribe.